Hello, it's June the 27th, 2019. Basically what we did is we took apart our Faraday disc and we decommissioned that. All the parts are going to scrap copper. I should do pretty good with that little box of copper. Should be worth at least 50 bucks. And we're going to reuse the parts because we don't have money to keep buying bearings and shafts and stuff. So, hello, it's June the 30th, 2019. So we got some more work done on the project here. Basically we got another alternator. We had to go over to Sundry to get this one and steal the core out of it. It was exactly the same, well, pretty darn close anyways. And then we welded up this, let's see if I can remove it here. I went and borrowed the welder from the guy I sold it to weld up these two nuts, so that now they're one solid piece, so that we can have this threaded extender onto the end of the alternator shaft. Just pop this off here, and basically it's not exact. It's out by about a degree or so, but it's pretty darn close. Like, it's close enough for the pulley to go on there, but it's out by maybe a half a degree or 3/4 of a degree, which isn't good. So although I was going to put the pulley on here like that, and then put the extender on, and then this would go inside this bearing like that, and then the whole works could spin off of this, but because it's out by a little bit, basically what we're going to do is we're going to change it up. And this is the front bearing housing that came from this alternator, and we're going to use it as our pivot bearing because it's the same size. And then what I'm going to do is I'm going to cut off this little protrusion here so that it's all flush, and then I'm going to have these two washers will sit in there like that, so that when we put this board on there, we'll bolt in this board, it'll all be kind of somewhat level. So this just kind of levels it, and then I'll put another bolt here. We'll drill these out with 1/4 inch holes. Now I have 1/4 inch drill these out with 1/4 inch as well, and set it up like that. And then this will be the mount off of this bearing, which will be our pivot bearing for the whole system to spin on. And then we'll what did I do with that threaded piece? There it is. After we get that on, this will get bolted onto here like that, and then we'll put this pulley on here, and this will then rotate the bearing on the inside of here at about 3000 RPM, which will rotate the bearing on the inside of there, so that the rotor is rotating at 3000 RPM. And then the back end I'll show you after I get this part here all finished. And then still have to wire it up and get the diodes in there and everything as well. I should actually run over to Active Electronics if they're even open, and pick up a couple of I'm gonna need 6 bridge rectifiers. 3 for sure, but if we can get 6, that'd be good too. Maybe I should do that. I'm gonna run over to Active and get some bridge rectifiers before they close, and then maybe we can get this darn thing all put together this weekend, which would be alright. But it is coming together. It's a work in progress, and it sure is a lot of fun building all this stuff. Whether they work or not, I'm having a blast just building them. So anyways, that's it for now, and we'll chat later. Bye bye. Okay, so we're back working on this. We were able to cut this housing. You can see that we cut it pretty flush, so that it sits level with this board. What did we do with that piece? I think it fell down here somewhere. This is what we cut off there. This is the piece that was on there. We just trimmed it right off there. So there's sure made short work of it with this bandsaw. Cuts through aluminum pretty darn easy. Just got to measure it up right and pray, and then the good Lord guides it, right? So that worked out pretty good. So then I put this pulley on here. It's a little bit off-centered, but see if you can see that it's a little bit off-centered. But there's not much we can do about that. So what we're going to do is just going to run it like this. It should be close enough for what we do, for what we need to do. It's like a millimeter out, but oh well, right? Not much we can do. So now I'm going to flip it over and get the other back end of it put together, and then I'll show you what that looks like after that's all done. Anyways, till later. Okay, so we have this slip ring assembly all rebuilt. We took out the smaller gauge wire so we could put in this 14 gauge wire, which will handle a little more current, and we have 8 amp bridge rectifiers, so this will be able to handle the current, and then this one here these two here will go for the DC pulse for this rotor, which I'll tie into this one here. But we'll trim the wires and get them connected proper. I drilled 2 holes to bring the wires through, and as you can see, the slip ring assembly and the pulley are all tied to this housing. So basically this will be on a bearing here. This is already on this bearing. So what we'll do is we'll have a pulley on this one, which will rotate this one counterclockwise. And then we have a pulley down here, which you can see there. This one's going to rotate clockwise, so that we're going to have 3600 RPM difference, potential difference, but maybe 500 RPM, 600 RPM of that will be the outside housing rotating. And I'm hoping that by doing that, we're creating electricity through these coils, which right at conception they'll be impregnated with the relative centrifugal force, and I'm hoping that we'll be able to extract the centrifugal force out of these coils in this manner. I wound them around the outside of that iron core. I worked on it quite a few years ago, but then I forgot what I was building because I had to work for like 28 days. By the time I got back to it, I lost sight of what I was building, so maybe this is what I was supposed to build, I don't know. But I got back to it here this week, and it's coming together, and we'll see what we can do with it. I should be able to assemble the unit into here pretty soon, and then we'll get it all leveled up, and then that's probably all we'll do for today. We'll come back on Monday and get this all wired up and maybe do some testing on Monday. But it sure is a lot of fun building this little unit. I'll just back up here a bit so we can see it all together, and then hopefully it'll test out pretty decent. Anyways, that's it for June the 30th. Let me get my camera going here. June the 30th, 2019. Bye-bye. Okay, so we're working on this again. You can see here that we have the unit all mounted now, and it worked out pretty darn good. That we just needed a 2x4, while a 3x2 over here to hold this in. A 2x4 would have been perfect to bring that right up to the edge, and this side here is pretty darn close. And then I just got to tighten up this bolt here, but you can see now that the outer housing with these RCF coils, it rotates independently than the inner housing, which is over here, because we have this main bearing here and this main bearing here, which everything rotates on, and then the inside core has another set of bearings here and another set of bearings, well, back in there. So the inside core is rotating in the original alternator configuration, and then we just took the front end off of that other alternator and we trimmed off that section. It worked out pretty darn close. The good Lord was guiding us there, and it landed pretty flush, And then this board here, when I bolt it on, it just fits flush with this 2x3 in there. So now is all that I got to do now is take all these coils, and I got to wind them in a way so that every third coil, 1, 2, 3, this one and this one, will be opposite in the way that I wind them. Because every third position is going to be a south. This will be north, and then the third position will be south, and then the third position will be north, third position will be south, all the way around for 12 positions in total. And then all we do is move over to the next one and then do the same third position, because this is phase 1, phase 2, and phase 3. So we're skipping over the phases, but we got to keep the phases to themselves, right? Like each in phase coil needs to be with its proper phase partner. So we'll wire these ones like positive and negative, and then this one here we'll wire it negative and positive. So we're going to actually reverse the wiring between this one and that one, so that we can get the proper polarity as well as the proper phase, because they have to be right if this is going to work at all. So the thing I like about this design over, say, building that one there, is that one's so big and bulky, and I don't have a welder anymore. I had to borrow the welder from the guy I sold it to, just to finish this here, and it does pretty decent welds, that other welder. So I think it was just the helmet that allowed me to see what I was doing a little bit better. So if I ever have money again to buy another welder, I'll make sure I get a decent helmet so that I can actually see the work I'm doing, and then that'll be half the battle as well. So this one here would have been very difficult to build, and well, without a welder it's going to be impossible to build. So we're just going to stop on that, get this one here all finished up, and I'll probably just disassemble that and send that steel plate off for scrap. That's all I can really do. And then I got to get all my scrap metal there together, and I have a couple boxes going already. This one here is scrap steel, and this one here is scrap copper. And the guy says that copper goes for like $2.50 a pound for scrap. So yeah, we spent $250 on that sheet, which is only going to get us maybe $10. If we're lucky, we'll get $10 for it. So that's not very good. That's less than 10 cents on the dollar. 2 cents on the dollar. But oh well, that's just the way it goes. I'm glad that this came together pretty decent. It sure is moving pretty easy. Everything's rotating very smooth, so that's pretty good. And I'll be mounting 2 motors on here. I'll be mounting a motor to turn this one clockwise and this one counterclockwise, or this one here I want to rotate counterclockwise and this one clockwise. So we'll figure out how to do that as we go. I might just try if this is going to rotate easy enough to just put a 12 volt DC motor on it, because I got a 12 volt DC motor right here. It's not here, this is a switch. I converted that motor to a switch, but we have this one here, this one right here, which might be able to rotate that as fast as we need it to go. Either that or we'll burn that little motor out, but it rotates really easy, so shouldn't be too bad. It was able to rotate the Faraday disc, which was really difficult to rotate. That had so much drag on it, it was unbelievable, all those brushes on it, and of course there's 2 bearings. But we will tackle this one stage at a time, and have to get it all finished up on Monday, because it's back to work Tuesday, Wednesday, Thursday, Friday, Saturday. Then I get Sunday off to worship the Lord and rest, and it's back to work Monday to Friday again. So I probably won't get another good day off to work on this for a couple weeks. But oh well, that's just the way it goes. When you don't have money, you don't have a choice, and oh well, right? But I'm glad this has really come together, and yeah, it'll be awesome to test it and see what kind of numbers come out of it. Anyways, that's it for June the 30th, 2019. Till next time. Bye bye.